Good morning, my dear students. In this particular video presentation, we'll discuss some more problems on probability meant for students of 9, 10, 11 as well as 12. Actually, the first problem goes like this. These are just definitions: define, event, experiment, impossible event, sure event, mutually exclusive events. Actually, we'll think of an experiment. When we throw a die, when we select a ball from a box containing different colors of balls, when we select a card from a well-shuffled pack of 52 playing cards, those are all considered to be various experiments. That's the meaning of various experiment. And when we think about an experiment, the set containing possible outcomes is called the sample space, and any subset of the sample space in general is considered to be an event. The event which will never happen is called the impossible event. For example, when we think about tossing two coins, the probability of having 3 heads, maximum we'll get only 2 heads. I can't have more than 2 heads. The probability of having 3 heads is an impossible event. Then when you think about sure event, the event which will definitely occur is called the sure event. For example, when we throw 2 coins, the probability of having at least 0 head, minimum 0 head, you mean none are, both are tails and 1 head and 2 tails. It will include all the entries in the sample space. It's an example of sure event. Or when we throw a coin, when we throw a die, let us say, when we throw a die, the event of getting a number less than or equal to 6, you'll get 1, 2, 3, 4, 5, 6, every number will be there. All the numbers, the sure event will be there. It's an example of sure event. Then if you're going to think about 2 events whose intersection is empty, those events are said to be mutually exclusive events. When you think about throwing 2 coins, A be the event of getting 2 heads, B be the event of having 2 tails, there is no common element. Therefore, here is an example for mutually exclusive events. Those are examples of mutually exclusive events. Okay. Then you have next question which goes like this. Write the probability of an impossible event. Write the probability of sure event. P of an impossible event. Just see here, it's not at all a difficult task. It is very simple, which is nothing but P of empty set, which is n of empty set by n of s, which is 0 by n of s, which is 0. Then P of sure event, which is supposed to be is equal to P of S, which is n of s by n of s, which is equal to 1. Therefore, probability of impossible event will be always 0 and probability of sure event will be always 1. These are the things you are supposed to think about anyway. These are all various possibilities where you can have such questions in MCQ for, if possible. You should know anyway the meaning of all such questions. Then find the probability of having imaginary roots of x square minus 36 equal to 0. I repeat, x square minus 36 equal to 0. Find the probability of having imaginary roots of x square minus 36 equal to 0, which implies x square is equal to 36, implies x equal to plus or minus 6. Here both the roots are real. Both of them are real. Therefore, P of having imaginary roots of x square minus 36 equal to 0 is 0. This is an impossible event. I can't have any of the roots of this equation to be imaginary. Therefore, here the answer is 0. This is an impossible. You can even take this for granted as an example for impossible event. Okay, example for impossible event. You can take this as an example. Okay. Next one, find the probability of selecting subdivision 1 a red ball, a non-red ball, a blue ball, a black ball, a white ball from a box containing 5 red balls, 3 blue balls, 2 black balls. There are 5 red balls in a box. Okay, then 3 blue balls in the same box, and of course 2 black balls in the same box. Okay, subdivision 1, P of selecting a red ball. Okay, it will be, I'll write it as number of red balls divided by total number of balls. Number of red balls divided by total number of balls, 5 by 10, which is half. This is the first answer for the first subdivision. Okay, P of selecting a non-red ball. P of selecting a non-red ball. Other than number of non-red balls. Divided by total number of balls. Okay, here other than red balls, there are 5 non-red balls. The probability here is also half. Okay, there are 3 blue balls, 2 black balls. Total number of non-red balls will be 5 by 10. Answer is again half. Then think about the third subdivision. P of selecting a blue ball. Okay, then number of blue balls by total number of balls. It will be 3 by 10. Then of course subdivision 4. P of selecting a black ball. Okay, how many black balls are there? 2 by 10. Answer will be 1 by 5. Then subdivision 5. P of selecting a white ball. Here it is supposed to be number of white balls is 0 by 10, which is 0. It's an example of impossible event. There are only red balls and blue balls and black balls. Now for P of white balls is not at all possible. We can't think of selecting a white ball. For P of selecting white ball will be 0 here. Therefore, P of selecting a red ball will be 5 by 10 half. P of selecting a non-red ball will be again 5 by 10 half. P of selecting a blue ball will be 3 by 10. P of selecting a black ball will be 2 by 10, which is 1 by 5. And P of selecting a white ball will be 0 by 10. Last one can be even treated as, of course, you can even think of it as an impossible event. Last one can be treated as an impossible event. It's a very simple result. How many colors of balls which we need? We'll think about that will be my numerator, and total number of balls will be my denominator. That will give you the answer automatically. It's not at all difficult for anybody to follow. Such a question may be there for students of 9 and 10. Okay, it may be an easy question for students of 11 and 12. Such a question may be there for students of 9 and 10. It's very simple. Okay, next I'll give you one more question. A class has 100 students. The probability of selecting a girl is 3 by 5. Find the number of boys and number of girls in the class. Okay, listen carefully. Let the number of boys be number of boys, or number of girls, even you can say number of girls be x. Okay, let me think about number of girls be x. Okay, I'll assume number of girls to be x. Okay, P of selecting a girl. Okay, P of selecting a girl is equal to 3 by 5, which implies x by 100 is equal to 3 by 5, which implies x equal to 3 by 5 into 100, which will give you 60. Now for number of boys equal to, number of boys here will be 100 minus 60, which is 40. Therefore number of girls in the class will be 60, and number of boys in the class will be, number of girls will be 60 and number of boys will be 40. It's very simple to follow. It's not at all difficult. It's not at all a difficult task. Rest we'll discuss in the next video. Thank you students for patient watching.